What's up? Hello everyone, my name is Johnson Jarel Yapan and I will be the one who will discuss the episode 4 of this mini-series, and I will be discussing the priority scheduling, which is an important CPU scheduling technique in operating systems. I will discuss how it works, its types, and examples and calculation, and its advantages and disadvantages. But before that, we will go on a brief introduction about my topic. So, priority scheduling is a CPU scheduling algorithm in which the processor selects the process with the highest priority for execution. The priority of each process is predefined, and the processes with higher priority are executed before those with lower priority. This algorithm can be implemented as either preemptive or non-preemptive. So, what's exactly these two types called preemptive and non-preemptive? Well, priority scheduling can be classified into two types. In preemptive priority scheduling, a currently running process can be interrupted if a higher priority process arrives. In non-preemptive priority scheduling, once a process starts execution, it continues until completion, even if a higher priority process enters the ready queue. So how does this actually work, you might ask? In priority scheduling, each process is assigned a priority value. The CPU always selects the process with the highest priority from the ready queue. If two processes have the same priority, they are scheduled using the first-come, first-served method. The scheduling behavior depends on whether the system is preemptive or non-preemptive. It is important to know that some of important terms used in priority scheduling include arrival time, which is when a process enters the system, and burst time, which is the total CPU time required by the process. Priority represents the importance of process. Waiting time is the time a process waits before execution, and turnaround time is the total time taken from arrival to completion. Now let's take a look at this example process table. Let us consider an example with three processes, P1, P2, and P3. P1 arrives at time 0 with a burst time of 5 and priority 2. P2 arrives at time 1 with a burst time of 3 and priority 1. P3 arrives at time 2 with a burst time of 4 and priority 3. Here, a lower priority number indicates a higher priority. Now let's explain the scheduling. At time 0, only process 1 or P1 is available, so it starts executing first. Although process P2 arrives later with a higher priority, P1 continues execution because this example follows non-preemptive priority scheduling. After P1 completes, P2 is selected next due to its higher priority, followed by P3. Let's take a look of the Gantt chart. The Gantt chart shows the order of execution. Process P1 runs from time 0 to 5, followed by process P2 from time 5 to 8, and finally process P3 from time 8 to 12. This visual representation helps us understand how CPU time is allocated among processes. Now let's go to the calculation. Based on the Gantt chart, we can calculate waiting time and turnaround time. The waiting time for P1 is 0, for P2 it is 4, and for P3 it is 6. The turnaround time for P1 is 5, for P2 it is 7, for P3 it is 10. Now, the average waiting time in this example is approximately 3.33 milliseconds. Now let's proceed to the advantages of priority scheduling. Priority scheduling has several advantages. It ensures that important or critical processes are executed first. This makes it suitable for real-time systems and environment where certain tasks must be handled urgently. It also allows flexibility by assigning priorities based on system requirements. Priority scheduling has some limitations. First is low priority process may suffer from starvation or high priority processes keep arriving. Despite its advantages, priority scheduling has some limitations. First is low priority processes may suffer from starvation if high priority processes keep arriving. The system also requires proper priority management, and the algorithm may not always be fair to all processes. So, what is the best use cases of priority scheduling? Priority scheduling is best used in real-time operating systems, critical task-based systems, and environments where tasks have different levels of importance. It is especially used when some processes must be completed before others. Now, to end this video, in conclusion, priority scheduling is a CPU scheduling algorithm that executes processes based on their priority instead of arrival time. While it is efficient for handling important tasks, it can lead to starvation if not properly managed. Thank you for listening. This is Jansen Jarel Yapan. I hope this explanation helped you understand priority scheduling, and goodbye.